Hello, Professor Yi. This is Jasmine, and I have chosen to do my physics video on surface tension. So I chose this topic because I wanted to test my mom's soap that she uses to wash dishes. I wanted to see how much it would reduce surface tension as like compared to pure water because the surface tension and how much it reduces it is going to basically determine how well it cleans the dishes when she uses this soap. So I'll explain all that later on, but I'm going to do an experiment that involves soapy water, pure water, water dropper, and a few pennies. Okay, here we go. All right, so I have my pure water, my soapy water, and my dropper, and my array of pennies. Then I'm going to need to show how this works. So what I'm first going to do is I'm going to use the pure water, put it in the stopper, and then we're going to see how many drops I can put on the penny before the water spills off of the penny. So let's see how this works here. So I'm dropping the water on the penny. We've got about 5 drops on here so far. And it looks really cool because you can see the water sticking together and forming this cool bubble on top of the penny. I've got quite a few drops on there already, and I just want to show this really cool layer of bubble that is on the penny. If I can zoom it in close enough to be able to tell. There we go. So you can see that extra layer of bubble. So if you're wondering, like I am, why in the world it took so many drops for the bubble to break and why it even caused a bubble, this is surface tension. The reason why a penny is able to gather water together like this. And I never thought water could be known as sticky before this experiment, but now I have a different kind of perspective on it because it is in fact sticky. The water sticks together and forms this cool looking bubble until it breaks. So this is because the molecules of the water are attracted to each other. They pull together and they cause a bubble to form. The attraction is what kind of minimizes the surface area. So you have more water, the same surface area, but you've got more water that's able to kind of come together and just stay on top of it. Okay, so that's cohesion, the molecules attracting together and basically like they kind of bond to each other. So now we're going to use the soap, and we're kind of going to see how the soap differs from the regular water. So I've got the soapy water here, which is what I put in here. You can tell it's soapy because it's got soap in there. And I'm just going to pour a few drops on here. And it starts to, oh, there we go. See, it starts to kind of form a bubble, but then it really just breaks apart really, really easily. Let's do it over here, and I'll try to be careful and try to get as much water as I can on there. And it really has a hard time forming that bubble. The soap interferes with the attraction of the molecules to each other, and so that's what's making the water wetter as opposed to stickier, which is what it did with the pure water. Okay, so what does this tell us about my mom's soap? And why am I convinced now that what she uses probably helps our dishes get cleaner than if she were to use no soap or a different kind of soap? Well, soap has water repelling parts and water attracting parts. So what it does is instead of just attracting water to water, the water molecules don't just attract to each other. Since it has both parts of it, it allows the water to attract to not just each other, but to whatever is on the dishes, so the grease and the dirt and the oil and all that good stuff. But then it also attracts to the other water that's on it, so that water can help wash away the dirt and all that other stuff. So one part of it attracts to the dirt, one part of it attracts to the water, and that's how we get clean dishes from soap and mixing it with water. So there we go. Go buy some soap and wash your dishes. Thank you so much. Bye.